Hi folks, welcome back to Math with Captain Rod. This is meant to be video number 3 here for your notes in 17.1 about circles. So it says, and I quote, find the equation of the circle with radius 3, center at the point 2 minus 3, and sketch it. So again, think back to algebra class when you're dealing with lines. The first thing you typically do when you're trying to find the equation of a line is write out one of the generic equations for a line, which is typically y equals mx plus b. Kind of the same thing here. I'm going to write out a generic equation for a circle, which is x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. And now we're just going to try to figure out the values for h, k, and r. So those values are sitting right here. It's centered at the point 2 minus 3. So h must be 2, k must be minus 3. So this can be written x minus 2 squared plus y minus a minus 3. That's going to be y plus 3 squared equals r squared. R being 3, and if you square that, 9. So there's the equation for this circle in standard form. Now it says to sketch it, so I'm going to go ahead and go to the center. Let's see, 2 negative 3s, 2 over, 1, 2, 3 down. I'm going to put a green dot there. 2, 3, because this is, again, not actually part of the circle. This is just a point we're going to use to sketch. Now the radius is 3, which means if I go 3 over, 1, 2, 3, there's a point, 3 up, 3 left, 3 down. Sketch it. Pretty rough sketch, I realize. And again, my coordinate axis here, remember this distance and this is not the same. I'm going to fix that later. That's a pretty rough sketch. You should have that a little bit better in your notes. And you need to be able to tell what all, these points, like what is this point right here? So it was the point 2, negative 3, and this is 1, 2, 3 over. So that's now the point 5, negative 3. This one we went 3 down. So that's the point 2, negative 2, 3, 4, 5, 6. And here we went 3 left. So if we start at 2 and we go 3 to the left, we're now at negative 1, and then negative 3. And then here we're 3 up. This is now the point 2, 0. All right, so that's probably good enough on that. I think I'll go ahead and pause this and set it up for number 4. All right, folks, I'm back. So I skipped one problem there. I'm going to let you do, what was it? Forget what, but where was I? Oh, number 4, where it says find the equation of a circle that goes through the point negative 1, 2, and whose center is at the point 3 minus 1. Just write out the standard form of a circle, x minus h squared plus y minus k squared equals r squared. H is minus 1, k is 2. You're going to have to calculate the radius. I'm going to let you do that. Just ask in class if you have trouble. But to calculate the radius, what you do is calculate the distance between the point negative 1, 2 and the point 3 minus 1. Right? I have confidence that you folks can get that done. I'm going to move on here and talk about these next set, which are quite a bit more difficult. All right, so the next set of problems say, let's see, to write the equation of the circle in standard form and sketch it. And here's the first equation we're seeing here. So the first thing you always want to do is write out the general form of a circle. And the next thing we want to do, we don't need this here, is try to make this look like this. And the method for doing that is everyone's favorite method, completing the square. All right. And for added fun, there's actually 2 things we have to complete the square on, the x terms and the y terms. So the first thing you typically do with this is get these x terms together. Leave yourself a little space because we're going to want to figure out what are we going to have to do to this thing to make it a perfect square. Now I'm going to group the y terms. Leave yourself a little space because we're going to have to figure out what are we going to have to add to that to make it a perfect square. And then usually you put the numbers, the constants, over on the right. So this 22, it's on the left. To get it on the right, you'd have to subtract it from both sides. All right, so all we've done here is just rearranged it, group the x terms, group the y terms, put the constant on the right. Now the reason for the constant on the right, look at the standard form of a circle. It's got this numerical value on the right. All right, now we got to complete the square on two of these terms, this guy and this guy. So to complete the square, we look here. This value in front of the x, cut it in half. That's minus 5. It doesn't really matter if you carry the minus sign with us because the next term is square it. That's 25. So I'm going to go ahead and add a 25 here to make this a perfect square. Now if you add 25 on one side, you have to add it to the other. I think, give me a moment here, I need a little more room. Okay, there, plus 25. All right, now this guy, we'll just put him on pause for a moment. Let's take a look at this. Now we want to turn this into a perfect square, and what you do is you look in front of the y term, we look here, take that value, which is 2, cut it in half, that's 1, square it, which is 1. Have to do both sides, so if I add a 1 here, I also have to add a 1 here. So addition of 25 will make this a perfect square, addition of 1 will make this a perfect square, and you have to maintain equality, so you either have to add these terms on the right or you could subtract them somewhere on the left, either one. Here it makes the most sense to add it to the right because of where we're going long term here. We're going to need that numerical value on the right. All right, this guy now, by design, is x minus 5 the quantity squared. This, by design, is y plus 1 the quantity squared equals negative 22 plus 25 is 3, plus 1 more is 4. All right, so what can we glean from this now? X minus 5, x minus h is 5. Y plus 1, y minus k is minus 1. 4 is equal to r squared, so r is equal to 2. And that's enough info to sketch this guy. I'm going to go ahead and put the center in, but I'm going to put it in a different color. It's not actually part of the graph of the circle. So 5 minus 1. 1, 2, 3, 4, 5 minus 1. All right, so there's our center. Now, because the radius is 2, that means if I go 2 to the right, 2 up, 2 to the left, 2 down, those are all points on the graph. Sketch this in a nice, perfect way. Look at that, absolute perfect circle. If this looks a little kind of cockeyed to you, you might want to get your eyes checked. All right, so these points here, again, remember this was the point 5 minus 1. This one's 2 more to the right, so that's 7 minus 1. This one's 2 more to the left, that's 3 minus 1. 2 more down, so that's, let's see, 5 minus 3. 2 more up, that's the point 5, 1. Now, I'm a big believer in intercepts. Intercepts are very important for graphs. My standard rule of thumb with every class I teach, whether it be physics or math, is any graph you have should have the intercepts drawn and labeled. I'm going to try to start modeling that in this class a lot. So we have intercepts here and here. Now these are x-intercepts, so we're going to find them by setting y equal to 0. Now where you do that in this work doesn't really matter. We could do it here or here. I think this would be a nice easy place to set y to 0. So if we set y to 0, this equation is now going to read x minus 5 squared plus, now setting y to 0, this is just going to be 1 squared. And we'll start solving for x. So we can subtract 1 from both sides. Square root both sides. Keeping in mind that when we square root both sides, it can be plus or minus root 3. And again, that's because this thing here, by time we square it, is going to be positive, whether that thing in green is net plus or minus. So that's why we get two solutions out of that. Then you just solve for x. So that's going to be 5 plus or minus root 3. So this coordinate right here in red, the coordinates of that point is 5 plus root 3, 0. And that one right there is, oh, I'm sorry, comparing these two roots, that's the smaller x value. That's 5 minus root 3. That was my bad. And then this one is 5 plus root 3, 0. I know you're tempted to want to say, well, can we, put decimal approximations here? You can. Those are now just approximations. It's either one is, I think, acceptable. So let's see, we're at 11 minutes on that video. So I think what we'll do is we'll stop that one right there. I hope that this helps with how to graph circles. Have a great day.